So that's why logical thinking also plays a very important role actually. Okay, I mean it's all about logical thinking actually. I mean how one can, what you call, if they solve one problem, how they can solve many problem. It's all about logically understanding the problem actually. Okay, pick up. But I mean that will fail when you have conceptual problem. Okay, not all problems are logical. Okay, concepts are inward actually. Okay, speak up. Hamiltonian of a quantum particle of mass m confined to a ring of unit radius. Is that okay? You can see here. So h bar square by 2I we used to write like this. Am I right? I is equal to, pick up, m into a square, but unit radius a equal to 1. That's why a is not there. Okay, pick up. So where theta is an angular coordinate, alpha is constant, the energy eigenvalues and eigenfunctions of the particle. Energy eigenvalues and eigenfunctions of the particle. Speaker. Look into this one carefully. Now theta is nothing but phi now. Particle moving on a ring, one angular coordinate that they define. Now you should not stick to that one. I mean, from one problem, how do you solve many problem? You should not stick to that one actually. I mean, you should grab only logic out of this. Then only you can apply the similar logic to many problems. Am I right? Speak up. I mean, if you are stick to that notation, that what you call problem, if you are confined to that one, pick up. Then you can't apply it anywhere. Okay. If you grab only logic out of that one, you can apply it in many places. Am I right? Pick up. Theta is nothing but phi. I will take phi. Why not? Okay. Pick up. H bar square by 2m. Okay. Minus I dou by dou phi. Okay. Minus alpha the whole square. Okay. Pick up. I'll solve my problem. I mean, I understood one problem, particle on the ring. In my way, I will solve this problem in that. I mean, using that idea. Okay. Pick up. Now look at here. Pick up. You need its energy eigenvalue of this Hamiltonian. Now what is the idea? Can you guess?
Expand that.
Huh. Write this one in terms of LZ and then expand. Pick up. H bar square by 2m. So multiply and divide by h bar. H bar is required. 1 by h bar into LZ cap minus alpha the whole square. Pick up. So that is nothing but h bar square by 2m. Okay. What is this whole square? LZ and alpha into I, you can take identity. I mean, this whole thing is operator. Am I right? Pick up. So they commute actually. You can write a square plus b square plus 2a. I mean, when they commute, if both are operator, if you are taking square, then be careful while taking square. Okay. Pick up. Can I write like this? LZ cap square by h bar square. Okay. Square of this one plus alpha square, or alpha square I'll write later. Okay. Minus 2 alpha by h bar. Okay. LZ cap. Okay. Plus alpha square. What is the eigenvalue? Speak up. LZ eigenfunction is the eigenfunction of this one. You can just check this out. Alpha into I, alpha square into I here. Identity operator. I mean, if you form eigen identity operator into e power im phi, what you get? E power im phi, isn't it? It's also eigenvalue equation, isn't it? Identity operator means do nothing. Don't ask what kind of operator it is here. I mean, there in matrix we write some matrix. Here, I mean, it means doing nothing actually. Speak up. A return point. This is alpha square along with identity operator. Okay. That's why e power im phi is my, again, pick up, e power im phi by 2 phi. It's again my eigenstate. I will say like this. What's wrong with that one? Not solving problem ideally. Solving problem ideally means you should square it. You should solve that differential equation. You can do that one. It's not so big deal, but time consuming. Okay. Pick up. I mean, squaring that one, and h psi is equal to e psi, solving the differential equation. Okay, I don't know whether they are expecting that one or not, but I will do in my way. Okay, pick up. Now, what is its eigen function? Eigen function is e power im phi by root 2, which is LZ eigen function. LZ is there, LZ square is there, LZ square eigen function is also same. Speak up. Eigenvalue, okay? Energy eigenvalue, that depends on m in my case, okay? Speak up. Here you convert it into n. Okay, speak up. What is that one? Speak up. H bar square by 2m. Hmm. Lz square eigenvalues are h bar m the whole square divided by h bar square. Speak up. Minus. Huh. Obviously, I mean, actually, why I squared this one because why I'm not trying to handle as it is because this may be non-linear operator, isn't it? Hmm? That's why I was worried actually. But when I square it, it looks like it is linear operator. It is linear operator. Check this out. Okay. Pick up. I mean, I thought like that. I was trying to solve directly. Okay. So that you will get direct answer. Okay. Speak up. I mean, by taking this operator as it is, but you can't feel it actually, like what you can feel here. Okay. Speak up. Minus, okay, minus 2 alpha by h bar into what is Lz? H bar into m. Okay. Speak up. Hmm? H bar into m plus alpha square, simply alpha square into identity. If you have identity operator, what is the eigenvalue? 1. Am I right? Speak up. So this is nothing but, I think h bar got cancelled everywhere. H bar square by 2m. Okay. M square minus 2 alpha m plus alpha square. Isn't it? Speak up. H bar square by 2m. What is this one? M minus alpha the whole square. So just replace m by n. I mean, you have to take n. Why? M is mass here. You have to take n here. Okay, speaker. There is no other option. Okay, so n here. Okay. N here, n here. Okay, n is integer. Okay. So, but the problem is this logical idea. Okay, speaker. It's very hard to convince other. I don't know whether you have experience or not. Okay, n here. Whatever logical way you do, okay, you can do. You solve. You believe that one, but it's so hard to convince others actually. N is equal to 0 plus or minus 1 plus or minus 2. Don't forget. Okay, isn't it? I quickly solved logical. I applied many logic. It's so hard to convince actually. Okay.
Sir, then why did we expand the square and not directly? Like, what is the reason?
No. I thought, I mean, this is a kind of derivative operator, square. It may be non-linear. I thought like that initially. That's why I expanded. Okay. But this is linear operator only, isn't it? Second derivative, first derivative, alpha. Am I right? If you form a differential equation, that's a linear differential equation only. I mean, I thought like that. That's why I have expanded. I mean, or if you, how do you find?
Directly
I can't quickly write eigen value and eigen function of this one. This one. I mean, oh, sorry. Okay, what I'm saying here is, okay, whatever the operator you have here, okay, Lz cap minus alpha, okay, the whole square, am I right? Pick up. I mean, can you think of its eigenvalue and eigenfunction directly? Oh. No, what I'm saying is, okay, when you operate it, you are operating twice actually. You can do like that. Lz by h bar minus alpha the whole square. Am I right? Pick up. This is nothing but Lz by h bar minus alpha into Lz by h bar, speak up, minus alpha. Am I right? Speak up. Now you can do.
logic equivalent to directly right.
Yeah. No, I mean, what if it is non-linear? That's what I was thinking actually, but it is linear. Okay, speak up. So now, if you operate, I mean, e power im phi. That's what you need to guess. Or in phi. Okay, in phi by root 2 phi. This should be This is your eigenstate, okay? Pick up. If you operate twice, okay, pick up. If you operate once, what would you get? Lz by h bar minus alpha. Okay, if you operate once, okay, what would you get? H bar n by h bar minus alpha. Okay, e power in phi by root 2 phi. Am I right? Pick up. If you operate twice, eigenvalue should come twice. I mean, this whole thing you can imagine as an operator now. That's also a good idea. Okay, pick up Lz cap square by, sorry, Lz cap by h bar minus alpha the whole square. Okay, so this is one eigenvalue equation you can see. Pick up. Once you have eigenvalue equation, square of that operator, you know what is the eigenvalue. So e power im phi, sorry, m is coming, our earlier symbol. Okay, e power in phi divided by root 2 phi. Pick up. This is equal to h bar n by h bar minus alpha the whole square into e power in phi divided by root 2 phi. If you thought like this in your mind, that's right. Not You be careful. That's what I'm saying. Okay, be careful. Speak up. Or there is another way actually to solve the problem. Can you tell me why? How? What is another way? I think that is bit also time consuming. You just operate this operator on this one, whether you check whether this is eigenvalue or not. Operator, expand. Okay? Operate it on this one, check whether you get this one or not. I mean, differential equation solution. Okay? Well, how do you define differential equation solution? Solution is the one which satisfies the differential equation.
What if that is the last option?
What if that's the last option? Okay, now, okay, I mean, you start with option A. Okay, pick up. Okay, you got it. It's okay. If I place this option here, pick up. That would be time consuming. Okay, pick up. I mean, suppose if you don't have tools, if you have time at the end of the exam, you can do that one. Okay, all four options. Okay, worth actually. Okay, so now speak up. Quantum particle of mass m moving in a horizontal circular path of radius say, particle is prepared in a quantum state. Okay, speak up. If measurement of z component of angular momentum particle carried out, the possible outcome corresponding probability is asking probability. Now comes all coefficient, weightage, everything is important now, isn't it? Now, how do you do this one? How do you do this one? Now look at here. I will do in my way like that. I mean, because probability also should be found. Am I right? You do it later. I will just rewrite the function. Okay. Psi, I'll write a here. I don't care about this one. Okay. Pick up. What happened? A by 4 as earlier. Am I right? E power I into 2 phi. E power I into 2 phi plus e power minus I into 2 phi plus 2 times. Am I right? Speak up. E power I into 0. Am I right? I'll multiply by root 2 phi. Okay, I'll divide by root 2 phi. What's wrong? What's wrong with that one? I have thrown this one. I call this one as A actually. Pick up. Don't make problem lengthy. Okay, you can do only algebra. You can do only algebra. Okay, so now 1 by root 2 phi. I needed this one 1 by root 2 phi to write normalized eigenstates here. Am I right? Speak up. Normalized LZ eigenstate. That's why A root 2 phi by 4. Okay, these are, I mean, along with this root 2 phi inside, these are normalized eigenstate. What is this one? Psi 2 of phi plus psi minus 2 of phi. Pick up. Plus 2 into psi 0 of phi. 2 into psi 0 of phi. These are normalized. Now this whole thing I will call it as B. B into, okay, psi 2 of phi plus psi minus 2 of phi, okay, plus 2 psi 0 of phi. Speak up. I mean, this 1 by root 2 phi is required to define the state actually. Don't leave as it is 2. You should write in terms of linear combination of eigenstate. Okay, I mean, don't keep only 2 into 1. You should write what is the state. I mean, linear combination of state. You can see here, isn't it? Even though it is 1 by root 2 phi. Okay, don't keep it as it is. Okay. Now, what is this one? How do you normalize this kind of state? Speak up. I mean, if you take this one as C1 into C3 into psi 0. Am I right? Speak up. Mod C1 square plus mod C2 square plus mod C3 square equal to 1. Am I right? Speak up. What is that one? So mod B square, that is common. Okay. Pick up 1 square plus 1 square plus 2 square. That's 4. 4 plus 2, 6. Am I right? Pick up 6. Am I right? Pick up B is equal to 1 by root 6. That's why psi is equal to, speak up, 1 by root 6. Speak up, psi 2 of phi. Speak up, 1 by root 6 psi minus 2 of phi plus 2 by root 6 psi 0 of phi. Okay, speak up. Probability of getting 2h bar, 1 by 6. Probability of getting minus 2h bar. I mean, when you do LZ measurement. Okay, speak up. Minus 2h bar, that's also 1 by 6. Okay, probability of getting 0h bar, that's equal to, speak up, 4 by 6. Okay, I'll keep it as it is. Is that 1 when you add? Yeah.